Cool It, a mathematical experiment involving exponential decay. Hi, my name is Udi, and today I'm going to talk to you about exponential decay using an experiment I executed. Exponential decay can be seen visually or solved mathematically. In my experiment, I used a special calculator tool with a thermometer on it that measured the temperature of the boiling water we had put in a mug every minute. We graphed these results into 5-minute intervals. The graph on the next slide will show you the water temperature decreasing every 5 minutes during the course of our experiment. If you look here, the points that are made along this area are the actual results. Now, you can clearly see this is not a linear decrease because there's a curve like this, and it doesn't go straight down. Now, there's the other way of finding exponential decay is if you look at the table, how when we started over here, the temperature was 184.65 degrees Fahrenheit, while after 5 minutes, it went down to 166.19 degrees Fahrenheit. Now, the third way to find exponential decay, and also the final way, is if you just calculate it using the equation. 184.65 is our starting temperature, and you subtract 0.98 to the power of however many minutes have passed, and that will give you the total temperature, and 0.98 is the amount of exponential decay. The next graph will show you the temperature difference between the boiling water and the air during the course of the experiment. Again, in this graph, you can clearly tell this is not a linear graph. It has a nice long curve that shows that it exponentially decreases. There's a large gap between the two points up here, and when you come down here you can see that this amount gets smaller and smaller. So again, you can use the table here to see that it's exponential decay. The amount that it decreases by decreases every 5 minutes. It goes to 97.49, and then to 80, and then 68, and then 58, and then 50. You can clearly tell this is becoming, that the difference every 5 minutes becomes less and less. Now again, the final way to find the amount of exponential decay is you use the equation. Now in the beginning the difference was 121.86 degrees Fahrenheit, which is right here, and you have to subtract the amount of exponential decay, which happens to be 0.96, to the power of however much time you have, which is along this column over here. You subtract that number from the beginning temperature and you'll be able to find what the next temperature is going to be. In the end, I learned a lot of different ways to find exponential decay. I could use the table or the equation to find it mathematically, or I could use the visual representation of the graph. Thanks for watching.